Good morning. Today I am going to present one of the topic in analysis of design and analysis of algorithm. And the topic I have chosen for today class is divide and conquer strategy. Before that, we should know what is an algorithm. Everybody knows this algorithm is, you might have studied in the first semester itself. Algorithm is nothing but a steps to solve the problem. We can say it's a kind of template. So to solve a particular problem, there are a lot of algorithms are there actually. But how the one algorithm is different from another algorithm based on how much time it is taking to solve the problem, how much memory it is occupying, that is very important. So in this course we will see all analysis of algorithm. Different algorithms are there, how to analyze each and algorithm. So basically, as I said before, algorithm is a template to solve any broad range of any type of problem. It's a diversified problem to solve. We can use this as a template. Second, once your algorithm is written, it can be converted into program using high level language. With the help of any language, the program can be coded as a the algorithm can be coded as a programming language. Third one is very important aspect, that is time and space. This temporal and spatial requirement is very essential for any algorithm. How much time it is taking to solve the problem, how much space is taking to store the variables and all other things. So in this survey, divide and conquer. Here we have taken today's topic as divide and conquer. This is one of the algorithm paradigm. What do you mean by paradigm? We can say divide and conquer strategy or paradigm. It's nothing but an approach. It is we can't say this is based on the strategy. We can write on our own algorithm to solve the problem. So this is one of the design strategy or paradigm. What this paradigm says, what this strategy says. See, any problem, if problem can be of any size, instead of solving the problem directly, you divide the problem into smaller module or some sub problem, and solve the sub problem independently, and put up all the solutions together to find the solution of main problem. So how much sub problems can be decided based on the nature of the problem as well as size of the problem. So from the name itself we can make it up. What is divide and conquer? What is conquer? Divide means what are the problems there, divide into. So for example, divide the input data S into two or disjoint subsets. Here all are independent problem, not dependent, because actually this should be solved independently. So the problem is S, and divide the problem into S1, S2, S3. Each S1, S2, S3 are the sub problem. Okay, and solve the sub problem recursively. The conquer word is specifically it is used in this strategy. It indicates you solve the problem recursively. What do you mean by recursively? If you do the same activity again and again to get the desired result, that we can say recursive or iterative, something like. So solve the sub problem recursively. That is the word actually meaning for conquer. Sorry, conquer means combine the solutions S1, S2 into original solutions. So divide, conquer and combine. Divide means divide the problems, conquer means solve the problems, and solve the problems recursively and combine the solutions. Okay, the base, while dividing the sub problem should be of constant size. You cannot divide the problem in independent size, it should be a constant size. So how to solve the recurrent equations, how much it is time taking, what is the time complexity? There is a theorem called master theorem. This master theorem in divide and conquer strategy, it's used to find the time complexity or find the time, how much time, and depends upon the size of the problem. Again, it is simply it's explained like divide the problem into two or more smaller sub problems, conquer sub problems by solving recursively, and combine the solution of sub problems into the solutions for the origin problem. If you find the solution for S1, S2, S3, S4, if you put up all the solutions together, you will get the solution for the original problem. So problem of size n is divided into two components, subproblem 1, subproblem 2 of size n by 2. If it is n means it is divided into 2 n by 2. Then find out the solution for subproblem 1 and solution for subproblem 2. Finally, you will get the solution to the original problem. Here one thing we have to notify that it doesn't mean that all the time the problem is divided into only 2. It can be more than 2. Most of the case it is 2. But don't assume that it always should be break up into 2 subproblem. Look at this example, this diagram. Look here, problem is divided into subproblem. Again, subproblem is divided into the green color subproblem, and then again divided into subproblem. So this indicates this subproblem. Here the problems are divided into independent subproblems. After this, it is difficult to divide the problem. So at this point we have to decide, we have to find out the solutions for these subproblems. So solutions for the subproblem 1, 2, 3, 4, etc. This stage, the beginning, the 1, 2, 3, 4 till layer 4 it is divide. At the layer 4 and 5 it is like conquer. You are solving the problem recursively, subproblem. Then combine the solutions of each problem. Then if you start combining, finally you will get the solution to the original problem. Hope you understood. See where this term came from actually. Divide and conquer, it is actually political, it came from politics. Before actually in history, if you see divide and rule is nothing but a combination of political, military and economic strategy. They put all the departments together in order to gain the power and maintain the power. Even though it is decentralized, but to have a control, gaining and maintaining the power, they have followed divide and rule concept. Here nothing but breaking up larger concentration of the power into smaller chunks, so that each chunk should have the less power than the main power. The same concept is adopted here in our algorithm approach. So why we have to go for this? Lot of strategies are there: divide and conquer, greedy, dynamic programming, backtracking. So many approaches are available. Why we have to go for divide and conquer? There are two reasons for this divide and conquer. One is parallelism and second one is cache performance. What do you mean by parallelism? See, when you divide the problem, each subproblem will be solved independently. That means at simultaneously you are solving the problems independently, subproblems independently. So automatically there is a parallelism, inherent, or we can say there is inherent parallelism. So automatically parallelism is adopted here. So most of the cases, real time application, if we see, this divide and conquer approaches are used in parallel computing machines, where you can solve the problems parallelly. We can go for this is one of the best method to write an algorithm or devise an algorithm. Second one is cache performance. What do you mean by cache performance? It's nothing. If you are accessing anything frequently, that will not be kept in main memory, that will be kept in cache memory, so that to improve the performance. Here also the performance cache will be very enormous, since once actually if we decide cache for a particular subproblem, the same cache memory will be reused by another subproblem. So only the data can be changed. Okay, so that means you are improving the performance through the cache. Otherwise, if you keep on dividing the problem, if you maintain m number of subproblems, and obviously there is a demand for the cache memory. So in that case, if already is allocated for one subproblem, that problem is solved. If another subproblem want to use that cache buffer, it can be used efficiently. So the reusability, here we are adapting reusability. So with this divide and conquer, the parallelism, reusability, in turn we are getting improvements of the performance improvement through the cache. These two are the important parameters for adopting the divide and conquer strategy. So let us see an example. Suppose you want to add n numbers and with the divide and conquer technique. So the a1 to an plus 1, it is divided into two category, like a0 plus an by 2, because total number is n. We have started from 0, so it is given as n minus 1, 0 n minus 1, and you divide this problem into two category. This is n by 2 minus 1 and it's n by 2 to n minus 1. Is it more efficient than brute force? You know what is brute force? Something we keep on trying to in order to get a desired result. That is brute force. It's kind of you can't say this is better than brute force. Almost it is equal. Some case it is more than that of brute force. Trial and Basin, brute force in if you see this brute force can be used in security domain. Suppose if you want to crack the password, you keep on trying trial and run. That kind of technique we can call it as brute force. Okay. Let us see example. There are 10 numbers are there. So the 0, 1, 2, 3 indicates the indices and the value for this array 2, 10, 3, 5, 7, etc. Here actually this array should be, or if you want to add all those numbers, it should be divided into 2. This problem domain is divided. So first 5 will be in one domain, one subproblem, and the next one is another array. See 0 to 4, 0, 1, 2, 3, 4 till 7, value 7 it is in, and next is 1, 6, 10, 1, 3. See here if you see the problem, the array size is 5, here array size is 10. Again you just divide into 2. Here if you take half of that, because 5 no, so first 2 will be one array and second 3 will be another array, and again you just divide. So 2 if you divide 2, 10 is, because this can't be divided because both there's no R and L and R will be the same. So only 2 elements, no need to divide, directly you can solve the problem. Whereas here there are 3 elements, again you can divide. This first element will be one array and second 2 elements will be another array. Okay. So let us see one example. Here we need to add all the numbers. There are 10 numbers are there. The array contains 10 numbers. We need to add all the numbers actually. So how we can solve using divide and conquer strategy? Here first you have to divide into the 2 arrays, and first array consists of 5 numbers and second array consists of 5 numbers, and next level this 5 numbers array can be divided into 2 arrays. The first array contains 2 elements and second array contains 3 elements, and again these 3 elements can be divided into 2 subproblem or 2 subarray. First this array, this is consists of, this is 3 and this is 5, 7. Look at this example here. 2, 10, 3, 5, 7, it is divided into 2 and 10 and 3 and 5, 7 another array, and here this is the smallest size, so this can be solved directly. So we have to add these 2 numbers, 2 plus 10, 12 will be there, and 3, 5, 7, this can be subdivided into 2 arrays. Here 3 will be in one array and second array is 5 and 7, then it can be solved directly. 5 plus 7 is 12, and then this 12 and 3 will be added 15, and 15 plus 12 will be added 27. This is the same way right hand side also we have to solve in such way. Here look at this subarray, it has 5 elements, again it is 2, 3, 2, this 2 will be solved directly 7. Here it again divided into 2 arrays, 10, 1 and 3 will be another array. So 1 plus 3 will be solved as 4, and 4 plus 10, 14, 14 plus 7, 21, and finally the solution for this problem, and this will be added, we will get the solution to the original problem. The output for this is 48. Okay. See, the number of addition is same like brute force, but to store the intermediate results we need to use the another data structure called stack. Okay. But another disadvantage is here, this divide and conquer will not work for all kind of problems. Okay. Mostly it is efficient for parallel processor or parallel computing. So what is the theorem behind divide and conquer strategy? So the master theorem is here Tn. Tn is time complexity, time required to solve the problem of size n. Okay, equal to a t of n by b plus f of n. Here a and b are the constants. Here the a indicates the number of subproblems. Any problem can be divided into different number of subproblems. Here a indicates number of subproblems, whereas b indicates the size of the subproblem. So each subproblem is divided into, each problem is divided into n by b of subproblem of size b plus f of n. Here this t of n b it indicates the time required to solve the problem, whereas f of indicates time required to divide the problem as well as combine the solutions. So time required for dividing and combining f of n, whereas t of n is only for solving the problem. So where f of n belongs to theta of n of k, this theta is nothing but a big O, it's time complexity, time required for the algorithm. We generally all the time can be represented by either small o or big O or theta. Theta is total time required to solve any kind of problem. So f of n belongs to, it can be subset of total time required to solve the problem. Here k is also a constant, we will see, and the condition for condition if a is less than b power k, here a, b, k all are constant, t of n will be like time required will be theta of n comma k. This is best case. A equal to b of k, t of n equal to theta of n k log n, whereas a is greater than p of k, b power k, total time required is belongs to our subset of theta n log b a. We will see with the example. So as I said before, it is time spent for dividing as well as combining the solution, time spent for solving the sub problem of size n by b. So look at this example. Here t of n equal to a, t of n by b plus f of n. Here a, the condition for this Master's theorem or divide and conquer approach, a and b should be greater than 1, where a can be greater than or equal to 1, but b must be greater than 1. And if f of n, that is time for dividing and combining, belongs to theta of n of d, where d is a constant, it always be the greater than 0. This formula you have to keep it in mind, so that we can calculate time complexity for any kind of problem. After solving the problem, we can easily calculate the time complexity. So t of n, again the same formula, order of n of d, theta of n of d if a is less than b of d. If it is equal to b of d, it means nd log n. If a is greater than b of d, here d is missing, a is greater than b of d means it could be log b of a. Look at this example, t of n equal to 3 n by 2 plus n. Here a is 3, b equal to 2, where n is like total time required for dividing and combining. Here n can be written as n power 1, so that to find the value of k or to find the value of d, you can say anything. So here a will be 3, b will be 2 and d will be 1. So a 3, b 2, f of n belongs to theta n power 1, so d equal to 1. So a equal to 3, which is greater than, what is b power d? It is 2 power 1, which is 2. So 3 is greater than 2. A is greater than 2, which category it comes? It comes this third case. So the time complexity is n log 2 3, n power log 2 3, the base is 2 and the value is 3, so the value will be 1.58 something. So look at this 3 t n by 2 n squared. Here a is 3, b is 2 and d is 2. So what is b power d? 2 power 2 is 4. So 3 is less than 4, a is less than b. Then in that case a is less than b means which will come? It will be the first case. So the time required to solve the problem is, look at this, order of n squared. N is 2, 2 squared we can get whatever value 4. So look at this third example, 4 t n by 2 n squared. Here a is 4, b is 2, d value is 2. So b power 2 is 4, a is 4. So a equal to 4, and b power d also 4. So the time required is order of n power 2 log n. So belongs to order of n square log n. So likewise we can solve our with the help of this theorem. Look at this, these are the not applicable case. Here 0.5, a cannot be fraction, a should be, as per the condition, it should be greater than or equal to 1, and it can't be like d also, it can't be fractions, d always greater than or equal to 0. The second case also, here the time required for solving the problem cannot be polynomial time, it should be a constant time. So this also doesn't apply. Look at this 64t n by 2. Here another thing is, once you all are positive value only, so negative value cannot be accepted. These are the invalid statement in this theorem. And a is a constant, at the same time a, b all are constants, we cannot give the fraction number for that. So and one more thing, in divide and conquer strategy, we cannot it's not necessary all the time you have to divide the problem n by 2. As I said before, it can be divided by n by b, based on that time can be calculated. This is a formula, t of n, a of t, n by b plus f of n. These things already we have discussed. When n is 1 or f of n is 1, when a and b are the same. This is one point we have to keep it in mind. When f of n will be 1 when both a and b are equal, not b power d. When a equal to b power d means it gives different time complexity. When the time required is f of n will be 1 when both values are same. Where it can be applied, this divide and conquer strategy can be applied in different algorithm: binary search, merge sort. These are the applications: merge sort, quick sort, mesh generation, Sarsen's multiplication, closest pair of points. Here we can't see all the algorithm, all the application now. We will see one or two examples during this session. Binary search. Let us see binary search. What is binary search? What do you mean by binary? Anything divided by two cases, 0 and 1. It is a binary. Binary search means there will be list of elements. It can be in the string or array in the stack. We need to find whether particular element is there or not. So the condition for binary search is the elements should be in the sorted order. By default it should be in sorted order. So how the binary search problem can be used, the divide and conquer strategy. So whatever the number of elements, it should be divided into two. The search space or solution space can be divided into two halves, because it is binary. No, it is two halves only. An item in a stored array of length n can be located with the, how many comparison is required actually for any number. There are log n comparison. If there are n numbers in the array, it requires log n comparison. Okay. For example, here the savings for there are 100 elements means it requires 7 comparison. If there is 1000 elements means it requires 10 comparison. If it is 10,000 means 13 comparison. This is the efficient way. So log n comparison is required to find a particular element in this array. Look at this example. Here there is an array consists of 12 elements. So the main thing is in binary search, when you divide the array or when you divide the string into two halves, we need to identify which one is leftmost element, which one is rightmost element, what is the middle element. So these three things is required: L, mid, R. According to this, here there are 12 elements. The top is index value, 1, 2, 3, 4 is index number. These are the actual values. So first L will be 1 and R will be 12. What would be the S? We suppose if it is even number, we can divide it correctly by suppose R number, maybe one array will have an extra element, another will have less element. Don't worry about that. L equal to 1, mid equal to 6% mid, and R equal to 12. So here in the first person 12 is there, 45 is there, 98. So if middle according to rule, actually left side will be the lesser elements, right side will be the greater elements, greater than the particular element, mid element. Okay. So suppose V mid. What is V mid? V of 6. V of 6 is 45. 45 is here the number. You have to find out whether the 70 is there in the string or in the tree or what in the array there or not. We have to search. So first we need to find out the V mid. V mid is 45. 45 is less than or equal to 70. Yeah, it's less than 70. It's true. Then we have to throw away the left side. So throw away the left half. Don't worry about, because it is lesser. So we have to go for next. So next what happened? Next we have to move the pointer. So now left side is what are the mid? 45. This left is 6 and mid is 9th position, and right side will not be changed. Right side is 12. Now you just compare. When you move, you have to compare whether X, because first we have compared, we have thrown off the left. So that means you have to assume that the elements will be in the right side. So now before you are comparing array element with your target element. Now you just look at this comparison. Your target element is 70. Whether you are comparing 70 is less than mid element. What is the mid element here? 73. So 70 is less than 73. True. That means you throw away the right side. So just throw away the right half. So the elements would be here, 45 to 73. It would be here. Then next step is So left side is again, left side will not be changing. Mid will be the 7 and right will be the 9, because you are fixing the, now right pointer will be moved to the 9. So the element will be here. Again you just check the same. V mid is 51. 51 is less than or equal to 70. Yes, true. Throw away the left. So left will be the, again the pointer, left pointer will be moved. Next L will be 7. Where is 7? L will be 7. Mid will be 8. 8th position, and right again you just repeat. V mid is less than or equal to X. True. Then throw away the left. Then again only two elements. At one point of time it will be both R minus L will be, if it is R minus L equal to 1 means there are no other elements, only two elements left and right. In that case we have to stop the algorithm. So this is the method how to solve. This is an algorithm. The same thing is written in the form of algorithm. See, look at this. Don't worry about this command line. L equal to binary search A and X. A is an array. X is the number to be searched, and look, L is equal to 1. By default left side, left L will be 1 and right equal to length of X, total number. In our case it is 12, while R minus L greater than 1. Why we have to put this condition? Because right minus R minus L equal to 1 means there are no other elements, only two elements. So it should be more than two elements. So that's why we are putting R minus L greater than 1 if it is mid floor. We need to find out the middle element. So L plus R divided 2. This is to find the middle element. If A is, this is the array element is X of if A the element to be searched, A less than R is X of mid, then R equal to mid, else L equal to mid. Likewise whatever we have done, we have put it in the point. If it is left means you just move the left pointer. If it is right means you have to move the right pointer towards end. This is algorithm for finding for solving binary search using the divide and conquer concept. Next we will see the merge sort. This is the difference between binary search and merge sort. You are sorting two arrays. Only things binary search there is a condition, it should be sorted array, but merge sort you can't expect. It could be sorted or it could not be sorted array. So but the same way we have to divide into array into sub arrays, and you can keep on solving the problem. I will go to the example directly. See, so you have to sort the array is given 0 to, when you write 1 to n means that is also correct, or when you write 0 means 0 to n minus 1. So it is divided into 0 to n by 2 minus 1, and the second array will n by 2 to n minus 1. Again you just sort this array separately and sort this array separately, then merge. We will find the, so this could be done recursively. So the example is subdividing. How here it is unsorted array is given. So you have to just divide. No need to sort it now. You keep on divide from by combining, while combining the solution, it automatically it will be sorted. So it will be divided. See, count the number of elements here: 3, 6, 9, 10, 11, 12, 13, 14, 15, 16 elements. So you have to divide 8, 8, 8. Then 8 will be divided 4, 4, 4 both sides. You keep on dividing 2, 2. When you become 1, 1, even when you become 2, this is the smallest sub problem size. So you start combining. While combining, you have to compare first element H and M. Whether H is lesser, or if it is H is lesser, it will go up. Okay. Then which is the next lesser element will be go. Because you look at this. Here it compares first E and H, which is, so E will be go and H, and here also G, MG, GM. Here BK as it is, because less AQ it will be as FL, PD, so DP, RC, CR, JN. Next it should combine this with this, the same concept. It will compare the elements of this one with this, then combine. So look at this here. E will go first. E is lesser than G, so E will go, and then G will be going next, and H, M. Like this we need to compare the first element so that we could identify the second slot. You can compare the next element. If we keep on merging, finally you will get the sorted array. This is the merge sort. The algorithm for merge sort here actually you can use either sorted or unsorted array. Suppose unsorted array means first what you sorted array you just assume sorted array is simple. You need to just compare two array and then move the output into the third array. Here look at this example. There are two arrays, B and C are the two arrays. Both are sorted arrays. you have to just merge into the third array. Sorted array means B is sorted in one way and C is sorted another, but while merging you have to compare which is less, and you have to arrange into ascending or descending order as per the requirement. So input arrays B and C and output is sorted array. Here the length of array P is the length of A array and Q is the length of B array. Sorry, this is B, this is C, and I equal to 0. These are the index variable, I for array B, J for array C, and K for array A, because A is a output array. So while I equal to less than P, length of first array, and J is less than Q, do if B of I less than or equal to 0, if it compares B and C. If it is less means whichever is less, that will be moved to a output array, else automatically the second array will have less value, so that will be moved to the A of K. So after moving you have to increment. If you are moving B to A, I will be incremented. If you are moving C to A, J will be incremented, and finally this is for output array K equal to K plus 1. Suppose if if it reaches the end of any one of the array, you can't expect all B and C will be the equal number of elements. Sometimes actually B will have more element, C will have less element, and vice versa. In that case, whatever may be, if I equal to P means just move the remaining balance elements of C into AK, or suppose else means automatically J will be reached to the end. So move the balance elements of B into K. Simple. See, this is unsorted array. The same thing, unsorted array, whatever we have done, it could be, we can solve both. Unsorted array, what you have to divide array, store into, this is unsorted array is given A to 0, you have to sort it and you have to write it back to the same array. So divide, copy A of 0 to, you divide 0 n by 2 minus 1 into B of this 0 to n and A of n to another array. Unsorted array, this is previous example we have seen sorted array. There are two sorted array, only we have done merging. Here one unsorted array is given. First thing is you have to divide and then merge. How will you divide? The array consists A0 n1, the same logic. Copy A0 n by 2 minus 1 to B0 to n by 2. Suppose 0 to 10 means it will be 0 to 5 will be in one array. Okay, suppose you just take 10 is n is 10, 10 by 2 how much? 5, 5 minus 1 4. So first 4 elements will be in array A, remaining 6 elements in the array, first will be in array B and the remaining 6 elements in array C, and the same way you have to do the merge sort and finally merge both arrays. You have to do this process separately and this separately, finally you need to merge it. The example is given. First it compares 2 and 1 because it is unsorted array. Then 1 is less, 1 will be moved, and then this pointer will actually, this will compare the next element. Then 2 will be compared with the 4, which is less 2. So 2 will be moved to the A. Then here actually 4 will be there. 4 will be compared with the 3. So 3 will be moved to A. Then 4 will be moved. Then 4 will be compared to the 8. So comparatively 4 will be moved. Then 8 will be there. 8 will be compared with the 5. So automatically 5 will be moved to the output array. Then 8 will be compared to 7. 7 will be moved and the remaining elements will be moved to the output array. This is given in the example. I'll just go through fastly this example. Look at this. Here how many elements are there? 3, 6, 7, 8 elements are there. So this is divided, this is totally unsorted array. This is array A. So this array is divided into B and C. B consists of 4 elements and C consists of another again 4 elements. Again this 4 elements array can be divided into 2 arrays. First array consists of 8, 3, second consists of 2, 9, and again this 8 and 3 is this is the sub problem divided into 2. 8 because while adding we have just, since to add 2 numbers, it's a binary, you need to have the array 2 numbers, but for sorting it's not necessary. That's why again for this problem we have again subdivided. In previous example we have seen actually there is a problem of size 2, because to add 2 numbers we should have at least 2 numbers, but here it's not necessary. You can have even sub problem of size 1. So it is 8 and 3 again divided the same way here, and then it just compare 3 and 8. So 3 will be lesser, it will go 3. The same way at this stage it is doing sorting. Okay, till here it is dividing the problem. Sub problem is divided, and then actually problem solving is happening here. So 3 and 8 and 2 and 9, which is less will be in the first position, 1 7 and 4 5. The same way again this is compared with the 3 8 is compared with the 2 9, it is combining. 1 7 is comparing with the 4 5, it is combining. For each comparison it requires log n comparison. The two elements means log n means it comes over 0.5 comparison line. So finally you will get the sorted array using merge sort by applying the divide and conquer strategy, because we are dividing and conquering at this stage and then combining at this stage. Okay. So what are the formula? Time complexity. So time complexity for solving this is required. T of n is equal to b. B is nothing but we have seen the size of the problem, b. If n is less than or equal to 2, it's a constant, it may be 1. So if n is less than or 2 equal means there is no comparison, directly you will get the answer. So b. Otherwise it uses t of 2t n by 2. This 2 indicates the problem is divided by 2. What are the problem is divided into 2 sub problem, plus b of n if n is greater than 2. This is a formula. Time complexity to just for merge sort is 2t the t n by 2. So the time required to solve the problem plus divide and combine. B of n is the time required to divide and combine the solutions when n is greater than 2. So we can see with the example, suppose t of n 2 n by 2 plus b of n. Again you are dividing the sub problem into 2 sub problems. This is first level. Second level again 2 sub problems. That means 2t n by square and b of n plus b of n by 2, because here n by 2, here it will be n by 4. So what you will get, 2 square t n by 2 square plus 2 bn. Suppose if you have first level 2 sub problem, again you have another 2 sub problems, then time complexity will be 2 squared n by 2. If you solve this, you will get this n by 2 squared plus 2 bn. Suppose you have one more level, then it will be cube 3 bn, another level 4 bn. Like if it depends upon the recursive level, it will reach as 2 power I t and divided by 2 power I is, it's nothing but level. How many levels you are dividing this upon, plus I bn. Okay. So note this is actually t of n equal to b when I equal to n less than 2, I equal to 1 means it will be like, this is ideal time, log n time it will take to short. Otherwise it is we can conclude time required to solve this problem using merge sort is b of n plus b of n log n. This can be represented in this form. Okay. So thus t of n is, this is best time. Best time to solve this, t of time complexity is order of n log n. Okay. Worst case of merge sort is order of n log n. Here see best case, this is best or whatever n log n. Worst case is order of n log n. Average case also n log n. It is compared to quick sort and other sort, this merge sort is somewhat stable, because you can fix up the time. How many sub problems you have, how much you can fix up the time complexity. There is no unprediction in merge sort. But only one problem actually here, in parallel processing sometimes you need to solve the problems parallelly and quickly. In that case we can, instead of here so far we have seen it is divided into two way. Multi-way merge sort is there. We were merging only two sorted array into one. So more than 2 can also be possible in the parallel computing. In that case it occupies extra memory and that is also challenging work. The last one is quick sort. Okay. Another divide and conquer, here quick sort also it uses the same strategy. Only here there are two challenges are there. One is here it uses the concept called pivot, identifying or locating pivot element as well as what are the partition technique. In previous year there is no technique, it simply it does into 2 way or 3 way, there is no logic behind the dividing. but here in quicksort we are using some of the partition techniques. It depends upon the problem we are using. There are mainly two partitions are there, Lamoto partition and Hori partitions. In general in our textbook we all follow Hori partitions. See, in quicksort, suppose there is an array, it will be first beginning itself it is divided into two array, and middle element, that is, this is called pivot element. A of S is pivot element. As usual, the left side is lesser element and right side is the greater of A of S. Okay, all are less than ASS, and this is all the operations are happening here based on the pivot element. Where the pivot element, what is the location of the pivot element, based on the number of comparison and time complexity, all based on the position and value of the pivot element, mainly position. In merge sort, all work in combining and partial solution. In quicksort, it doesn't worry about actually combining the solutions. It does automatically inherently, but in merge sort we are doing explicitly all combining the solutions. This is algorithm for quicksort. Here L indicates left side, R indicates right position. Sorts subarray in quicksort, because here also arrays are divided into subarrays. So for solving for partitioning subarray, what is the formula here actually? If L equal to R, left side, L is R means there are some elements, left L is less than R means, so partition A L R, S is a split position, at which position it can be split. Quicksort A L S minus 1, quicksort S plus 1. How it can be done? As I said, it can be used any one of the pivot, with the pivot, any one of the partition algorithm. Look at this example. Here the first element is identified as a pivot element. In that case, actually, while identifying element, you have to, there is a formula, there is an array, you have to compare each and every element with the pivot element. Pivot element here in an array, any element can be declared as or identified as a pivot element. In this example, they have identified the first element as a pivot element. Then we start comparing A of I. First element, it will leave the first element. From the second element onwards, it start comparing with the pivot. If it is A of I is less than P, then increment I and stop. This is a continuous process. This is a recursive process, and stop when A of I is greater than or equal to P. Right? A of I is greater than or equal to P. The same way, parallelly, another variable starts from right position. That is called J. If A of J is greater than P, pivot element will be common only one. Left side it compares whether all the elements are less than P. Right side it compares all the elements are greater than P. When the condition becomes false, at that point it will stop. That means when A of I is greater than P, greater than or equal to P, it will stop. And when A of I is less than or P, A of J is less than or P, it will stop. Look at this example. It keeps going. At this point it is greater than or equal to P, it stops, I stops. Here the same way, J is less than or P, it stops. And then the another condition, it swaps the values. I and swaps the pointer, I and J will be the, see I will be less than, it swaps, first it swapping the value. This value will become here and this will go here. So J will come here, I will come here, the values will be like this. And then finally it just check the J is less than L. Suppose J is less than L, that again that value will also be swapped, that we will see with the example. So it's understood at this position J and I equal to equal. This partition element is A of 1, I equal to L, J equal to R plus 1. Repeat I, whatever I said, it is put in the code format. Repeat I equal to I plus 1 until A of I is greater than P or equal to P. Repeat J equal to J minus 1 until A of J is less than or P, and then swap A of I and A of J until these three statements should be repeated till I is greater than or equal to J. And then after swapping, if suppose A of I, you have to undo the last swap. A of I, just swap whatever we have done previously. Then suppose the J is less than the first element, that there also you have to swap. A of L and A of J should be swapped. We will see here. Here see the 5 is identified as a pivot element. The remaining I is at the position 3 and J is at the position 7, and the second iteration it just it keeps on, it compares 3 is compared with the 5 which is lesser, so increment I. So 1 is less than 5, it's lesser, it's increment. When it reaches 9 is less than 5, is wrong, so at this point it stopped. The same way here it compares j is 7 is greater than 5, so it is decrementing. 4 is greater than or 5, false, so it stops. So now I will be at the position 9 and j is at the position 4. Now what we have to swap the values. So 4 will come over here and 9 will go there. So 4, 9, then again it start the process. 4 will be compared to the 5, it is lesser, so increment, it goes to 8, and then 9 will be compared to 5, it is greater, so decrement, it goes to j. Now I is in 8 and j is in 2, again swap the values, 2 come over here and 8 will go here, and then here the one point we have to know, now we have to swap the variables also. Here we have swapped the values 2 and 8. Here we need, because in the previous slide we have done with the 2 swap. First we are swapping, then we are undo the swapping. So j will come over here, I will go here. J is 2 because we need to do the sorting also. Then j is compared with the first element, pivot element. So whatever the value of j, that will be compared to the pivot element. Suppose that j value is less than the first pivot, it just swap. So 2 will go here, 5 will go here. There are 3 things are happening, 3 swaps are happening. First it will just swap the values and then swap the variables, and finally it will compare the left and then swap. This is a concept, this algorithm we cannot change, we have to remember this, right? The same way it continues again, it keeps continuing, and finally you will get the sorted array. This is the logic behind the quick sort. Look at this example. Here actually there are, how many elements are there? There are 8 elements are there. In this array 8 elements are there. 0 to 7, 8 elements are there. Elements 5, 3, 1, 9, 8, 2, 4, 7. Here what is a left index value is 0. Right index value is 7. Middle value is equal to 4. Because 8 will be divided into 4. This is equal to 4. 5, 3, 1, 9 will be in one array. Middle value 4 is 8. See, look at this, s equal to 4. Again this array is divided into another sub array. Look, L equal to 0, 0 and 7 means, look at this example, how many elements are there? 1, oh they have changed the value, 1, 2, 3, 1, 4, 5. See, you just don't see the, compare the value here, this L equal to 0 here and R equal to 7 here, S equal to 4 means at the 4th position value 5 is there, that is rounded. Another, here you take this half of array, this array, here what is the value? L equal to 0, R equal to 3 and S equal to 1. If you divide, if you find L plus 4 plus 1, 5 divided by 2, you will get 2.5 or whatever it is. How will you find the mid value? Pivot value. Pivot value, there is no formula. For binary search you can identify any one of the value like. So here L equal to 0, R equal to 3, S equal to 1, and look at this array, L equal to 5, R equal to 7, S equal to 6, and again if you divide you will get only one element, both R and S equal to 0 here, and if you here right side it will be 2, 3, L equal to 2, R equal to 3 and S equal to 2, first element, and again if you divide this side, L equal to 5, R equal to 7, S equal to 6, again you can divide this element separately, L 5, R equal to 5, all are the same, only one element, and the right side only one element, L and R will be same, only one element. When you become single it is only one element. Here also L equal to 3, R equal to 3, here L equal to 2, L equal to 2, R equal to 3, okay. The same way like this is divided to whatever we have done before, the same thing, this L value, R value and middle value is represented here. There is no difference between the previous and this. So algorithm as we have seen before, What is the time complexity? See, suppose to cross over I and j, at one point of time I and j will cross over. For that it requires n plus 1 comparisons. When I and j are equal, when it coincides, we need n comparisons. If all split happen in the middle, it is a best case. Suppose all the split correctly, if you are able to split, then that is a best case, and the time complexity is best case time. So C of best of n is equal to 2 best of n by 2 plus n. The same thing, whatever the master theorem says, the same thing is applied here. It is 2 where we have given T of n b by n by b plus f of n, we have the same thing, C base n by 2 plus n for n is greater than 1. Suppose n is not greater than 1, it is a best case is 0 time, there is no comparison happening. Then what is the worst case? The same formula we can apply. Worst case, we have to, this is best case, worst case is if the number is like, you just look at this example, how many elements are there? There are 5 elements. So comparison, 6 comparisons required, 5 plus. Here again 4 elements. After that you are removing the lesser element from the array. 5 comparison, then 4 comparison, 3 comparison, and if you add all those things, actually depends upon how many elements are there. If you add all those value, n plus 1, n plus 2, n plus 3, n plus 4, like this, that will be the worst time complexity for solving this problem. It is represented as n plus 1 plus n minus 1 plus 1 plus 2 power n, like this actually, which is nothing but n plus 1 plus n plus 2 divided by 2 minus 3 into, why here it is a constant, 3 is a constant, and theta of n squared. So n into n minus 1 divided by 2 plus 1, actually it should be given, instead of that it is minus 3 epsilon. So you remember this worst case time complexity and best case time complexity. So this is average case. Most of the time average case and worst case all looks similar. Average case also, let's suppose pivot element is middle, that is average case, expected average case n minus 1 plus n. You just assume that while dividing an array, it all the time it would be then the middle. This is average case 1.39 n log n. See, quick sort is faster, the name itself quick sort, it is faster than merge as well as keep sort. Only problem is it's not stable, whereas merge sort is, we can say, is stable, and memory requirements for merge sort is more compared to this. And what are the, here also the depends upon the number of elements, the size of the problem, the complexity will differ from one method to another. So what are the things to be improved in quicksort? Some randomized quicksort, median of 3, we are identifying the only one element, the same way like multi-way merge sort, here also you need to find out the median value to find the pivot element, because locating pivot element is a challenging task. For that, if you use this median of 3 concept, it would be useful. And switching to instance sort, here even the quicksort, if we use instance sort while sorting an array, that could be efficient compared to this. And partitioning also, 3-way partitioning, instead of 2-way partitioning, if you use 3-way partition, it gives more response. So it's not stable, requires stack to store the parameters, and it can be made order of log n. Still versus even though if it doesn't do any work, it takes order of 1 time as well as space. With this we close little bit. This is how the same divide and this is very interesting. I'll take 1 or 2 minutes. See how this can be used, divide and conquer methods in geometric situation. Look at this example. Can you see anything here? This mesh consists of lot of triangles. All are triangles here actually. Lot of triangles are there. And how this triangle, this can be drawn with the help of divide and conquer strategy. This is recursive mesh generation. chop a region up to a triangles with the smaller triangles into the area of the triangle. You need to identify how many triangles are there, or you have to chop the region into smaller triangle with the divide and conquer strategy. This is mesh generation in 3D. See, let us draw this graphic. Why is mesh generation a divide and conquer process? It's completely, it uses the divide and conquer process. What is the logic behind this? If the triangle is big enough, you take one triangle, if it is big enough, it's a big triangle. If you are able to see the midpoints of a triangle, connect all those midpoints and color the triangle into pink color. Else, color the whole triangle into yellow. You will get the mesh. What are the mesh we have seen there? Look at this. This is the outside. This is a big triangle. The triangle is big enough. What is the midpoint here? Midpoint here. Here midpoint. Collect the midpoint and color it into pink color. And then, so look at this triangle. Or you will get, after that you will get 1, 2, 3 triangle. So you just take left triangle, connect all the midpoints, make it pink color. Again, you smaller triangle you will get, connect the midpoint and color it into pink color, and then you will get the smaller triangle. After that, it is not possible. If we keep on dividing the problem at the one point of time, it should stop. The same way you can see. You can fill up the, if you keep on filling up the triangle, then it gives the, if you repeat, it gives the, finally you will get like this. Suppose if it is not able to divide, you just make it the yellow color. You have to color it in yellow. If you are able to draw the triangle, if you are able to join the midpoints, you can draw the triangle and make it pink color. This is the algorithm behind this. But the only thing is, actually here we need to find out the levels, how many levels we can do it. Draw the triangle x and y level. Level equal to 5. The recursion limit should be given. We cannot keep on, when the problem size is smaller, another problem we say if it is 2 elements for adding 2 numbers, we can stop it. Suppose sorting, if the array has only 1 element, we stop. But in geometry, how will you stop it? So we have to give the threshold value manually. So if level is 5, then stop it. Recursion limit is reached. You make it yellow color and come out. Else, draw the triangle. You just draw the triangle, find out the midpoints, and then if it is able to draw the triangle, then draw the triangle and then just color it with the pink. So with this I would like to conclude, and today we have seen divide and conquer strategy, where it can be applied. The application, if you start, mainly it is applied in parallel computing and parallel processing area, and we have discussed 3 examples. One is binary search, merge sort, quick sort, and along with this coloring, what is it, what is that? Mesh generation, how it can be done with the geometrical, how it can be applied in geometrical field also. But compared to greedy and other backtracking, this divide and conquer is a beautiful strategy, because with the help of this strategy, it's easy to solve the problem, and again it has a lot of advantages as well as disadvantages. Depends upon the type of problem. We need to analyze the algorithm. Analysis of algorithm is very important, because everybody can write a program, everybody can solve the problem. In what way, how the problem actually, how the program is different from one person to another program based on the time and space. These 3 are the very important. How much time it is required to solve the problem, how much this performance, how much space it occupies, and speed. All these things depends upon the what kind of algorithm we are choosing, what kind of strategy we are choosing. So divide and conquer, as I said, divide any problem and solve the problem and combining the solutions. Okay, thank you.